Hi students, we're looking at note section 2.5 and that has to do with standard form. And so we are going to investigate a little bit more about standard form. But first thing to know is this is what standard form looks like. It's ax plus by equals c, and there are no fractions. And the a value is always positive. And so you can see numbers 1, 2, and 3 are all in standard form. One of the cool things about standard form is it's easy to find intercepts. So we find the x-intercept by looking at the x-axis, which goes this way. And wherever it crosses it, that's the x-intercept. And remember, that's x, comma, 0. If you are going to use algebra, you're going to use this information that it's x, comma, 0, and you're going to plug in the 0 for the y value, and then you're going to solve for x. The y-intercept, you look at the y-axis, which is the one that goes up and down, and wherever it crosses it. And then to solve for that, that's going to be the ordered pair 0, comma, y, where the x value is 0, and so you're going to plug in 0 as the x value to solve for y. When you're graphing, there are two options. Option 1, solve for the x and y intercepts. Plot them and then connect the dots. Option 2 is to solve for y like we did with literal equations so that it says y equals mx plus b. And if you want to do that, these are the steps. Converting to y equals mx plus b. You move the x and y. I'm just going to move the x to the other side, and then you're going to divide everything by b. But if you are converting it into standard form, then you're going to move the slope term with x to the other side, and you're going to multiply everything by any denominator so that there are no fractions. If when you did that the slope was negative, you'll just multiply by a negative number. Let's take a look at graphing these first three functions in standard form by finding the x and y intercepts. So this equation, when I find the x-intercept, that is x, comma, 0. So we plug in 0 for y. When I do that, the work looks like this. 2x plus 4 times 0 equals 12. Well, you and I both know that 4 times 0 is 0. So that cancels out, which is really cool. And then it just becomes 2x equals 12. So I think to myself, 2 times what makes 12? 2 times 6. So the ordered pair is 6, comma, 0. And I'll plot that 1, 2, 3, 4, 5, 6 on the x-axis. Remember, x goes this way. I do the similar work for the y-intercept by plugging in 0 for x. The work for that says 2 times 0 plus 4y equals 12. And that's 2 times 0 cancels out, and I have 4y equals 12. So 4 times what makes 12? Y is equal to 3. So that looks like this, 0, comma, 3, because it's always the pattern 0, comma, y. So I go up to 0, comma, 3, put my dot down, and I connect the dots. Oh, I missed one, but it looks pretty good. Let's do a little bit of work to translate number 1 into slope-intercept form. So when I want to put this in slope-intercept form, then that just means I wanted to say y equals mx plus b. So that's going to mean I take my equation, and I move the x term over, so I'm going to take away 2x. 12 and 2x are not like terms, so I have 4y is equal to negative 2x plus 12. And then I divide everything by 4, including the 2x and including the 12. Every part by 4. So then I have y equals negative 2 over 4. Let's divide both of those by 2. So negative 2 will become 1. 4 will become 2. Negative 1/2x, and then plus 3. This is now y equals mx plus b, so they're saying the slope is negative 1/2, down 1 and over 2. So down 1 and over 2, okay, I didn't get it. Down 1 and over 2, down 1 and over 2, yeah. So if I had used a straight edge, this would have been really, really good. So we don't have to convert it, but that's one way that we could graph. Let's look at number 2. We're going to find the x and y intercepts. So here I have 3x minus 9y equals 18. So when I find the x-intercept, I'm trying to find x comma 0. So that's going to be 3x minus 9 times 0, so nothing, equals 18. So 3x equals 18. When I divide by 3, I get 6. So I'm going to write 6 comma 0. I'm going to do the same work because I'm trying to find 0 comma y. This time plugging in 0 as the x value. So 3 times 0, nothing. So it's negative 9y is equal to 18. When I divide by negative 9, I get y equals negative 2. So that's 0 comma negative 2. So when I go to plot my ordered pairs, 0, negative 2, and 1, 2, 3, 4, 5, 6. Let's try converting this one into slope-intercept form to confirm that it looks like our picture. So to convert it, remember we move that positive 3x with a minus 3x. So that's going to be negative 9y is equal to negative 3x plus 18 because it was a positive 18. Then I divide everything by negative 9. And I end up with 9 divided by 9 is 1. Y equals negative divided by negative is a positive. And then let's divide both of those by 3. So it's going to be 3 divided by 3 is 1. 9 divided by 3 is 3x. And then 18 divided by negative 9, that's going to be a minus, and it's 2. And so that's saying our slope was 1/3, up 1 and over 3, up 1 and over 3. Gorgeous. We did a really good job with this one. Cool. Let's look at example number 3. So here in example number 3, we have 5x minus 8y equals 10. So I'm going to find the x-intercept by going x comma 0. And I'm going to have 5x is equal to 10. Why? Because the 8y canceled out. So then I end up with x is equal to 2. 2 comma 0. When I go to find the y-intercept, I'm going to plug in 0 as the x value. And that's going to give me 5 times 0, nothing. Negative 8y is equal to 10. Well, that one doesn't go in evenly, so let's do the math. Dividing by negative 8, I get y equals negative, let's divide those both by 2. 5 over 4. And if I have 5 quarters, that's $1.25, so negative 1.25. So I have to write it as a y-intercept 0 comma negative 1.25. So that's going to be hard to graph. Let me zoom in and see if I can do that. Still kind of looks like half. But that's what I got. So for all of these, we plug in 0 for x, we plug in 0 for y, and then we've got our graph. Look at number 4, how unique it is. This is x equals negative 3. So to graph this function, we're going to want to think of, well, when is x equal to negative 3? What are some ordered pairs that make that true? Well, for sure, negative 3 comma 0, right? And that would be right here. Are there any other places where negative 3 is the x value? What about negative 3 comma 1? Is that true? Yeah, the x value in that ordered pair is negative 3. So let's think of another ordered pair. Negative 3 comma 4. Okay, so yeah, negative 3 is the x value. What about something else. -3 comma -3. Sure. There the x and y are equal to -3. And so look at this pattern that's developing. What shape is it trying to make? It's trying to make that vertical line shape. And that's true of any x equals. It's a vertical line. It's not a function. So we use a vertical line to test every x value to see if more than one number is there. And here all the numbers are there, so not a function. So anytime we have x equals a number, it doesn't matter what y is equal to. Y can be anything, is what it's saying. It just matters that x is -3, and when you go and plot those ordered pairs, you find that it's a vertical line. So looking at number 5, we've got the opposite situation. So let's plot some ordered pairs here. We're already predicting though, hey, it's just y, there's no x. So here's my little hint. This is really equal to y equals 0x plus 5. It's really the y-intercept is 5, and the slope is 0. Of course, because 0 times something cancels out. So when I think of ordered pairs that have a y value of 5, it's something 5, something 5, something 5. Let me put those commas in, huh? And let's do one more, something 5. So of course, 0, 5. 1, 2, 3, 4, 5. What else? 2, 5. Okay. 3, 5? Sure. -9, 5? Yep. That would be right here. So all of them have a 5 as the y value, so when you draw a line between them, it's this shape, which is called horizontal. And remember, that's the easy slope, horizontal. That's the nice, easy walking sidewalk with no slope or a 0 slope. Those are the same. Now number 60 is crazy. Let me find the x and y intercepts. Let's just try it. So I'm going to plug in to find the x-intercept. It's x, 0, and then 0, y. So I'm going to plug in y equals 0. So I'm going to have x divided by 4 is equal to 1, because it was 0 divided by 6. So x divided by 4, the opposite of divide by 4 is times by 4. So let's times by 4 on both sides. So in this case, x is equal to 4, which is the ordered pair, 4, 0. That's not bad. Hey, I thought this was going to be harder. Well, let's do the next one. The y-intercept, so 0 for x, 0 divided by 4 is 0. So I have negative y divided by 6 is equal to 1. So y divided by 6, the opposite of divide is times. So I'm going to times by 6. But I also want to take care of the negative in one step. So I'm going to times by -6. That way the negatives will cancel out. I have a negative times a negative, which is a positive. Negative times a negative is a positive. Then the 6 cancel, so I get y equals -6, which is 0, -6. 1, 2, 3, 4, 5, 6. Graphing the line. Pretty cool. Very nice. So here we've got 3 more examples. We want to change these into standard form. So we're just going to do number 7, and then we'll do 8 and 9 in class together. So the first step is to, let's get rid of the fraction first. So the denominator of the fraction is 4. So we're going to times everything by 4. Everything. Every single part. So 4 times y, 4y, equals -1/4 times 4x. So we'll make that into one big fraction, plus 12 times 4. Okay. So I'm going to get rid of that 1 here because it was 1 times